All right, thanks for being here today, everyone. You can hear me okay, I hope. Looks like most of you are on this side, so I'll speak that direction. My name's Robin Beck. It's great to be with you today. I'm an education engineer. I write most of the educational content for Boundary. Yeah, really excited to share some of Boundary's latest and greatest features with you. In particular, today we're talking about session recording, and we're also going to be discussing Vault and integrating it with Boundary in order to kind of see the full capabilities of these two products when they're combined together. So glad you all could be here and join us. Before we get started here, I was curious, how many of you here have experience with Vault? All right. And how many of you have worked with Boundary before? All right, excellent. So this will be fun. And how about Terraform? Excellent. We always at least have some Terraform experience. So that's great. We're going to be using all of these tools today if you choose to follow along. And we're gonna get to the content kind of as quickly as possible because we do have a lot to chat about and a lot that I'll be demoing, and hopefully you'll be following along if you can. So firstly, we're going to discuss a little bit about just HCP Boundary and Boundary Enterprise. These are some of the capabilities that you get with those new products. And so session recording in and of itself is a capability of those kind of enterprise level of Boundary. Additionally, we'll discuss some prerequisites for session recording, and then we'll jump into the lab and wrap up with any questions before we finish up. So to start out with, I want to just mention here some of the benefits of working with HCP Boundary or Boundary Enterprise. That's really what we're discussing today. In particular, you get access to a few different capabilities that are required for session recording. The first of them are SSH target types. And in Boundary, this means that we have a particular way of communicating with a target that is designed to benefit or use the SSH protocol. This is super useful because in Boundary, we can generally open connections with TCP, but the SSH target type allows us to do things like protocol decoding, where we can capture the information inside of a session and record it within what we call the BSR, the Boundary Session Recording File Format. So this is what we're going to get into today, is the benefits of session recording, but an SSH target type is required to set that up. You get SSH targets currently with Boundary Enterprise or with HCP Boundary, which you'll be using. Can I ask, how many of you have used HCP Boundary at this point? Do any of you have an account with HCP? Great. All right. Well, that's what we'll be utilizing to get a kind of a running start here so that we don't have to deploy a Boundary Enterprise cluster itself. We're going to use the managed version of Boundary if you choose to follow along. That also gives us the ability to utilize credential injection. So within Boundary, we have the ability to pass sessions back to pass credentials back to clients when they request a session. So what is a session within Boundary? It's when you request that Boundary opens a connection for you to a target that you're trying to reach. And when Boundary does this, it has the ability to also pass credentials to the session itself. And without using Boundary Enterprise, we use a process called credential brokering, where these credentials are passed directly back to the end user, and the end user is then able to utilize them to log into those target systems. With credential injection, those credentials are never passed back to the end users. They are instead directly injected into their sessions so that the client doesn't have to manage credentials. Boundary handles that process for them. This is particularly fun when you utilize Vault in order to inject those credentials for you as well, which is the subject of today's talk. With all these pieces in place, we enable SSH session recording, which again is the ability to go ahead and record all of the activity that occurs within a session. What you'll see at the end of this is that we also have the ability to play back those sessions even inside of our browsers. So it's really great for auditing and for other purposes. The benefits of session recording are that we can really provide a system of record for network activity. And this is particularly useful for auditing capabilities or for checking out what happened on a system if you have a security breach or vulnerability. And this gives you, insight into those user actions over remote sessions, and we can mitigate malicious behavior this way. And the big benefit, of course, is logging all of the session activity for review later on. Lastly, this is important if you're trying to meet regulatory requirements. Sometimes having that system of record is really important and, in some cases, a requirement. So that's the benefit of session recording. Hopefully, you'll get to see that if you stick around to the end. And some of the prerequisites for today, if you choose to follow along right now, or if you choose to try this content later on, we're going to need access to a HCP Boundary Plus cluster first and foremost. So that's the very first thing I'm going to have you set up if you choose to follow along. And you could also do this with Boundary Enterprise as well. Next, we'll need to set up credential injection, which is a prerequisite to setting up session recording. This is, again, that process where Boundary handles the credentials for any sessions that you request to targets within it. Lastly, we'll need SSH target types, and then also we need to integrate with Amazon S3. So the last requirement for this lab is really utilization of an AWS account. So if you're lacking any of those prerequisites, you'll have a chance to get set up. But if this is too much for this moment, I'm sending you home with the lab content that you can try anytime you would like. So to be aware, the big prerequisites, HCP Boundary, we'll need to set up a Plus cluster to have access to these features. And then using Amazon, in particular, we're going to deploy Vault to AWS. And then we're also going to utilize the S3 storage backend during this session. Okay, so a little bit about kind of the reference architecture. It sounds like a lot of people here are kind of new to Boundary or haven't worked with this before. And in particular, I want to just bring up a short reference architecture diagram to give you a bird's eye view of what's going on with Boundary. You can see on this diagram that we have a user. The goal of that user is to access any target hosts that are within private network enclaves of some kind. In this particular situation, we're utilizing Boundary, HCP Boundary, as our control plane. So this is the process where the user is going to request a session to a target from Boundary, and Boundary then wants to forward the connection through the proper channels to reach those hosts. So this is a way for us to get access to those hosts without directly having, say, even the target credentials. To do this, we're going to request a session from Boundary, and Boundary then routes the user or the client through what we call a Boundary worker. Boundary workers are the systems that are going to provide access to private network enclaves for the user, and essentially we're going to hop those sessions from the client to the hosts. So you can see here this is divided kind of into the public internet, places where we can access these target workers, as they're called, and also HCP Boundary, and then private networks where we'd like to eventually forward the connection for the client. If you're new to Boundary or haven't tried this before, you should be aware that this is all based on trusted identity. Meaning to say that we're not using just network access here. We're asking who is that user and are they able to access or should they be able to access the hosts? And Boundary then determines whether or not they can establish a session to that host. And that's how this is different from using something like a traditional VPN. In today's talk, we wanted to, again, kind of give the bigger picture of what can happen with the integrations with something like Vault for credential management. So we'll also be utilizing, in this example, Vault and Amazon S3 as the storage backend to record sessions later on. So this is kind of a simplification of the systems that we'll be deploying today. We'll be using one worker to access our target hosts, and that worker will also be providing connections to Vault and Amazon. All right. So hopefully that gives you a kind of a bird's eye view of what we're going to be setting up. Today, the kind of deployment workflow we'll be following is we're going to use Terraform to speed along the process of setting up some of these components that we're going to need. Now, to be very clear, you don't have to use Terraform to do any of this, but we're going to utilize it to speed up the process of deploying Vault and to simplify it as well. So Vault in particular will be that credential management system for us. And we'll use Terraform to deploy Vault and then also set up some targets that we can access using Boundary within private networks. So for the Terraform section, we'll need to kind of review some of the configuration for Terraform. We'll then set some environment variables, and then we'll apply Terraform and check what we get back. That'll again be access to Vault and also the configuration settings for the targets that we want to set up within Boundary. Next, we're going to, on the AWS side of things, we're going to need to configure Vault and set up the credentials needed to access those targets. So with the AWS section, this is essentially going to be us logging into those Vault systems. We're going to configure Vault, and then we're going to grab a token from Vault that will allow Boundary to log into Vault and request credentials for targets. At that point, the last thing to do is to set up what are called workers within Boundary, which again provide access to those private networks. Without workers, Boundary doesn't have a way to reach into the private networks and forward your connections along to the target host systems. At that point, we'll be ready to go and jump into HCP Boundary, and we'll set up a few different resources within Boundary that are needed to enable session recording. This is including a list of targets that we want to access, which in Boundary are called host catalogs. Catalogs of the systems that you would like to access with Boundary. We'll then need to also set up Vault within Boundary to state where Boundary should get credentials for those targets. That's what we call a credential library. The last two pieces are that we need to set up a storage system for our session recordings. This is a storage bucket within Boundary that connects to Amazon S3 as the backend. And then lastly, we'll set up that target that we want to access, the SSH target, which we'll then connect to later on and record the activity that goes on that target. So to be really clear here, what we're doing with all this configuration is that we as administrators are creating a very simple way for our clients to access target systems. The goal of this is to show you the Boundary administrator workflow that's required in order to set up session recording. And then clients, the people that utilize Boundary on a day-to-day basis, have an incredibly simple workflow to connect to a target later on. So this is the admin portion of utilizing Boundary. So where can you access this content? I'm going to leave this up on the screen for just a moment. This is a link that you can follow to access our tutorial on developer.hashicorp.com. And if you're not able to follow along today, then you can try this later on by just visiting this tutorial. And the QR code leads to the same endpoint. So it just pulls up the tutorial if you don't have your laptops handy. All right, so feel free to pull that up. And if you do have any questions so far, feel free to raise your hand and we'll get someone over to answer them. And you can ask me a question if you'd like as well. All right, excellent. You should have access to this tutorial now. This is where that link goes. And if you aren't familiar with developer.hashicorp.com, this is the place where you can go to get started with Boundary more generally. So to be fully transparent, this is a very advanced workflow we're setting up within Boundary today. So if any of these concepts are unclear to you, don't worry. We have a lot of tutorials for you to get started with Boundary, including an HCP Quick Start collection that will take you through the process of getting started with Boundary, setting up the CLI, and all of the other components. In particular, I want to start by looking at the prerequisites for today's lab. And first thing I want to mention about this is that this has been tested in 2 locations, one on my Mac and 2 also on the WSL, Windows for Linux subsystem within Windows. So if you do have a Windows machine and you're following along, please do perform all the lab steps within the WSL if you have it configured. If you don't, you'll want to get that set up before you attempt this tutorial because it has quite a bit of automation that allows you to spin up all of these Vault resources within AWS. So to use that successfully, you'll want to open your Windows terminal, type bash, or if you have Ubuntu installed, that would be a great way to follow along with this as well. Any questions or concerns about that? All right. Great, so that's the biggest gotcha here as you go through the content. In particular, you will also need several prerequisites if you want to attempt this lab content. One is, of course, you'll need Boundary installed. We, in these prerequisites, link to kind of getting started pieces, but essentially you'll need to ensure the Boundary binary, the Vault binary, and also the Terraform binaries are all installed. Those three pieces will enable you to complete the lab without any trouble. But you will need those located in your path as you go through and get set up. So if you are setting this up within the Windows for Linux subsystem for the very first time, it may take you a little bit to get those tools installed. If you have any trouble with that, please call over one of our TAs and they can get you started. In addition to that, we'll want the JQ utility. It will be very useful for grabbing some outputs from Terraform that we'll need later on. And then also, you'll need to consider using make. Now, make is not required to complete this tutorial. However, I have created a bunch of functions that make it pretty simple for you to do some automation around setting up Vault and deploying Terraform using make. So if you do have that available in your path, it will make the tutorial a little bit faster, but we do have ways for you to get around using make that I'll show you in a moment. And again, if you're trying this on Windows within your Windows for Linux subsystem, you want to make sure make is available there as well. Lastly, the Boundary desktop app. If you have followed along with some of the announcements here at HashiCorp, you'll learn that today's Boundary desktop app that was available as of this yesterday has some pretty neat new features in it, including an embedded shell that we can use to access our targets. So I do encourage you to install that and try it later on. To be clear, that is different from the Boundary client or the binary itself. And the Boundary desktop app is what we expect the end users of Boundary to utilize when they want to access target systems. Today, we're playing the hat of Boundary administrator. And so we're setting up all these systems and then utilizing the client to access that later on. All right. If you haven't used Vault before, I encourage you to read through the concepts section of the tutorial. We've got a lot of great getting started resources for you here. But today we're going to proceed as if we have a little bit of background with that. I'm going to skip a lot of this background. We discussed kind of at a high level here what session recording is, and hopefully you'll have a more intuitive sense of what it does by the end of today's session. And we're going to jump straight into configuring the lab environment because there's quite a few pieces to put in place to get all of this functioning. The first thing I want to do is get set up on HCP Boundary. If you don't have an HCP account, I encourage you to head over to portal.cloud.hashicorp.com, the HashiCorp Cloud Platform, and I encourage you to get set up with an HCP account. With the Boundary section in particular, Boundary clusters get 50 free sessions every time you spin up a cluster. So this means that when you're learning HCP Boundary or taking any of the tutorials on developer.hashicorp.com, you can follow along for free as long as you stay underneath that 50 sessions limit per cluster that you create. So it's a great way for you to go about learning without having to spin up and manage your own Boundary clusters. And so this is what I would recommend to you. And I think the majority of you that I asked don't have HCP accounts. Is that correct? All right, great. Well, I encourage you to get signed up when you try this tutorial later on. I believe you will have to grab some credit card information and set up billing. But again, you won't have to pay any money as long as you start with those 50 free sessions with Boundary. So you shouldn't get charged for any of the HCP resources that you consume to complete this tutorial later on. So that would be the first thing that you'll need to get set up. And I'm going to go ahead and launch an HCP boundary cluster here to show you what that will look like when you try this now or later on. So within HCP here, I have opened up a project that does not have boundary configured inside of it. And this is what the dashboard looks like. You can see the boundary service on the left and this Get Started with Boundary section here that takes you to the boundary dashboard. Next, you'll want to click Deploy Boundary, and we'll want to select the plus SKU. We have two different kind of tiers here that we can use to deploy boundary. One is the standard boundary tier. This has a huge number of enterprise capabilities, including multi-hop workers. But we want to select the plus tier so that we get access to SSH session recordings. Most important piece as you get started with this is to make sure that your boundary cluster is set up to do session recording. Again, this is also available with our enterprise offering, our on-premises version of Boundary. Selecting Plus, I'll then create an administrator account for my new cluster. I like to create an admin user myself, and then I will set up a password of some kind. And be very careful when I'm typing that in so I know what it is. It's very cold up here as well, so I might fat finger some things. And as this is in the status of creating, we'll continue getting set up here. Now, additionally, to complete this lab, we'll also need access to AWS. So it's important to note that we're going to be utilizing a number of AWS services, including Amazon S3. We'll also be utilizing EC2, and I believe there's even some routing going on in the Terraform I set up. So you will need access to an AWS account that has essentially admin level privileges to create IAM users, to create EC2 instances, and also to access Amazon S3. So that's a prerequisite for today's session as well. And that will allow us to set up session recording and Vault pretty seamlessly. So if you do have access to that, you will need your access key ID for AWS, and you will also need your secret access key to use on the command line in just a moment. So if you don't have access to that, please do review some of the prerequisites here, and you're welcome to get signed up. The point of this is that we'll need access to those to deploy Terraform in just a moment. Any questions about that? All right, well, don't be shy if you do have questions. I'm sure someone else does. So feel free to raise your hand and interrupt me or call over someone with the mic. Next, we're going to continue getting set up, and we're going to grab some environment variables that we'll need to deploy Terraform and set up Vault and set up our targets on AWS. So the first thing we'll need are some boundary environment variables, including a boundary address, a cluster ID, and the username and password that we just used to set up boundary. To grab those things, you can head back to that cluster page where it's launching our instance currently, our plus SKU cluster. And you'll notice this section called cluster URL. This is the most important piece to make sure that you can log into Boundary. We can log into Boundary on the command line or using the web UI utilizing this cluster URL. So we want to copy it, and then we want to export it as an environment variable. So these environment variables are what we're going to be utilizing. And we'll export them, I guess, in just a moment. If you were to follow the flow of the tutorial here, the first thing they're going to do is have you copy down the lab content. This is in a GitHub repository, and you can clone it down in any working directory you would like on your machine. And this is what the GitHub repository looks like. Enable session recording with AWS. So if I were to copy this and head into my terminal session, I could execute the git clone and pull down that repository. And after doing so, you'll see a number of files that come with it. I want to give you just a quick tour of what's inside of this repository, so hopefully it makes a little bit more sense what you're about to deploy. And so in general, here's what we're going to be working with. We have 3 different directories inside of the lab environment for today. We have an infrastructure folder called infra. We have a scripts folder that's going to be used to set up some of those EC2 instances. And then we also have a Vault folder that contains some of the policies that we're going to upload to Vault to specify how it's allowed to communicate with Boundary and how it should manage also the secrets that live inside of it. Lastly, there's also the sections that are in the root of this repository, including some example Terraform code and a make file. So that's a quick tour of what's inside of here. Essentially, the infrastructure folder contains all of the AWS resources we're going to deploy, including some EC2 instances, some keys, some IAM users, and the S3 bucket, and some security groups and networking settings as well. So quite an extensive list of Terraform resources here. I'm not going to review all those in detail, but I encourage you to explore it and see what kind of resources we're setting up. The main things that I want you to be aware of as you go through this content are first the make file and the setup.sh script. The reason for this is that the make file just defines some very simple ways to interact with the lab environment, including a way for us to quickly apply or deploy Terraform and to destroy all of the resources associated with Terraform. Now, additionally, we have some extra functions that are inside of here, including setting up Vault, registering our Boundary workers, and also connecting to the Vault instance if we need to for some reason. And that's what the make file defines for us, and essentially it just calls some scripts inside of setup.sh. So if you're curious about what any of the commands we're about to run are going to do, those are the 2 files that you can use to learn more about this lab environment. For example, if I execute make apply, it's going to be responsible for executing Terraform and supplying some environment variables to it. So that's a quick tour of the lab environment. And now we're going to deploy our infrastructure. The lab environment is going to deploy 1 Vault instance, 2 Amazon EC2 target instances, a key pair for the EC2 instances, and then an S3 storage bucket and 2 IAM users. So that's the majority of what's being created on AWS for this. We're actually going to create less resources than you might normally if you were setting this up in a more production-ready environment. What I mean by that is that we're also going to deploy the Boundary Worker service on the Vault instance itself and the Boundary Worker service on the targets that we would like to access as well. So to be clear, usually in a more production-ready environment, these would be separate instances that handle the ingress connections from Boundary and forward those connections to any of the instances we're trying to access, the targets, or Vault when Boundary attempts to connect to Vault. But in order to minimize the amount of costs associated with today's lab, to make sure you don't get a big bill at the end of it, we're going to run the Boundary Worker services on those target instances. All the automation code for that is in those scripts directories. But to be clear, these are the list of resources that you're going to create when you spin all this content up. At this point, we're going to set some environment variables that will be utilized by Terraform, including your AWS access credentials, an AWS region you'd like to deploy these resources in, and then some Boundary credentials as well, including the Boundary address, the credentials that you set for that cluster, and also something called an authentication method ID, which is essentially the ID of the username and password that you used to log in to Boundary. To do this, you'll want to export these as environment variables inside of your shell session. So you can copy these and you can replace these values here to make sure the environment variables are exported correctly. I've already exported my access key ID and secret access key, but I do want to export my AWS region and set it to US East-1. And then also I want to then begin filling in the boundary credentials that we need. Now, a moment ago, I went ahead and copied the boundary address from the HCP portal. To grab that again, you'll head back into this boundary cluster section here. You can see my cluster is finished provisioning. And then I can copy this cluster URL. Once I have that piece here, I'm ready to go ahead and paste it into the boundary address section of the terminal. And additionally, we'll want to grab the username and password that I used to provision that instance a moment ago. So I called that user admin inside of there. And right here, you're going to see my password, so no one mess with my lab environment, please. And additionally, we also need what's called the cluster ID. The cluster ID itself can be determined by just looking at the boundary address. The cluster ID is this front portion of the boundary address that prefixes the .boundary.hashicorp.cloud. So we can simply copy that value and paste it in for the boundary cluster ID right here. And the last thing that we'll need to utilize is called the authentication method ID. We're going to log into Boundary and grab that. If I head back to my HCP Boundary portal, I can click Open Admin UI, and it will open that Boundary cluster's login page for us. And this is the first time you'll be logging into Boundary. I'm going to supply those admin credentials here. And the first thing Boundary is going to ask me is, do you have a target that you would like to test? This is the nice little quick start they've put together for you to easily utilize Boundary for the first time. We're going to skip this, though, and click Do This Later. Now I'm inside of my Boundary admin UI. And the first thing we're going to do is first visit the section on the far left called Auth Methods. Clicking on this page, you'll see what's called the password authentication method. And again, this is essentially just an ID for the password that you created when you launched the cluster. Authentication methods are ways of logging into Boundary. You can log into Boundary using something like a username and password, or you can also connect your identity provider, such as Okta or Azure AD, to Boundary. So these authentication methods are just ways of logging into Boundary, and usually you'd use your standard identity management software like Okta to log into Boundary. We're only going to grab the ID of the password auth method, because this is how we can administer Boundary as an admin user. And I'll paste that ID in for the Boundary auth method ID. All right, and now that I've exported those environment variables, I'm going to check that they've all been defined as I would expect using this echo command, and simply make sure that I'm not missing anything that I need to deploy the lab environment. And you can see all of those values that I set within the shell session. Next, I'm going to apply Terraform. So I mentioned the make file earlier. It's a very simplified way of managing the lab environment. And what I've done here is list a few make commands that can be used to deploy the lab environment and tear down the lab environment easily. The make apply command will do all that for you. And then when we're all finished, we want to ensure that we run make destroy to clean up the AWS resources that we create. So if you do try this at home, be aware that you're creating these AWS resources, and you'll want to tear them down at the end to make sure you don't incur a bunch of charges later on. If you don't want to use make, you can absolutely go through with the lab by utilizing these bash commands instead. Again, make is a quick way to alias a bunch of the things inside of that setup.sh script I showed off a moment ago. So if you wanted to execute make apply, you can copy this command and use bash to go ahead and run the apply function within the setup script. All right. Wanted to mention that there's a lot of people that don't like to use make, so I wanted to make sure we cater to them if they wanted to avoid using make files. All right. At this point, I'm going to execute make apply. Now, this is a lot of Terraform to run here, so it could take a few moments to go ahead and deploy all of the resources. Again, this is creating those Vault instances, the EC2 targets, there are 2 of them, an AWS or Amazon S3 bucket, and then also the keys that we need to log into those instances. There's some security groups that are needed as well. And the last thing I should mention are the IAM users that are being created that allow you to log into S3 and grab the storage backend and also do things like log into AWS and see what boundary targets we want to connect to. So there's a whole bunch of kind of boundary prerequisite concepts that are going on in this lab. So if you're not familiar with something like a host catalog within Boundary, it's the ability for us to ask Boundary to look at an AWS account and determine what hosts should be imported into Boundary. So a dynamic host catalog is something that I highly recommend you look at in the Boundary tutorials. It'll teach you to integrate AWS and Boundary. We also have host catalogs for Azure. So if you wanted to import Azure virtual machines into Boundary, we can do that too. You can also create all of those instances manually within Boundary. You don't have to import any of your hosts from the cloud providers, but it's a quick way for us to go ahead and say, hey, AWS, what are the targets that you want Boundary to connect to? All right. Lastly here, the make apply command is provisioning those instances that I mentioned before, including the Vault instance and the target instances. And it's also setting up the Boundary workers on those instances so that the Boundary control plane can speak to our targets. When we're all finished, we're going to see the Terraform output displayed from that script. And I wanted to mention that I put together a little make function that will display the Terraform output for you at any time. You could also run all these commands from within the infra directory. So if you're used to using Terraform, you could cd in there and run Terraform. But we have other scripts that we want to run, which is why I created these Terraform functions, these make functions in the root of this directory. All right, so you can see here that I've gone ahead now and finished the Terraform run. If I scroll up, I will see all of the outputs that you might like to take a look at. We had 80 resources that were created, and you can see some IDs of things like the AWS IAM users. You can see the storage key IAM users. And notice that these are sensitive values. So we'll need to grab their outputs later on. But additionally, we can also see the targets and their IP addresses, and also the Vault DNS and IP address as well. And we can also see some tags that are associated with the instances that we just deployed. This will become important in just a moment when I tell Boundary how it should look for all of the instances that should belong to Boundary. So in AWS, we're able to tag our virtual machines or our instances, and these tags can be utilized by Boundary to say, hey, Boundary, I want to import all of the targets from AWS that are production targets. So I give Boundary the tags from AWS that should be imported into its host catalog. Hopefully that makes sense. Tell Boundary, hey, what targets from AWS do you want to use? And we say, grab all the targets that have this env equals dev tag. If you need to see this output at any time, you can run make Terraform _output, and it will reprint all of that output for you, just so as you go through the lab, you can easily refer back to those values. Next, we want to configure Vault. We've made this pretty simple for you using make as well. And in particular, we want to go ahead and tell Vault, first we want to grab a way to log into Vault. And I'll do this by grabbing a root token from the Vault instance itself. So the make Vault root token command goes ahead and logs into that remote Vault instance, and it copies the root token to this local machine. So I'll execute the make Vault root token command. It's going to ask me if I want to connect to this machine via SSH or SFTP, I believe it is. I'll type yes. And then it goes through and logs into the Vault instance and copies that root token to our local machine. You can see that it gives me the values that I need to export from the output. So when you run these make commands, I have it echo the output here to the terminal. And what you need to do now is copy the Vault address and the Vault token and export them as environment variables so that I can do things like log into Vault and configure Vault from this machine. So after grabbing that root token and exporting these environment variables, I'm now going to set up Vault. Now this is going to involve logging into Vault and then copying some of the policies that Boundary needs in order to communicate with Vault correctly. So what is Vault doing for Boundary? Vault is going to provide credentials to log into these target systems. We're going to supply static SSH keys for all of the instances that we would like to log into, but you can also set up Boundary to use things like SSH certificates, if you would prefer, to create dynamic credential sets for Boundary. So that's what we're going to set up within Vault, is to write a policy for Boundary to be able to look up those tokens, to renew its lease, and then revoke those values as well later on. Additionally, we need also the ability to read the credentials that we write to Vault. Now, again, to simplify the amount of resources we're deploying with AWS, I've only set up one single SSH key that we load up into Vault to log into our targets. And that's just to limit the amount of cost for this lab inside of AWS. So I'm going to create one secret within Vault. I'm calling it SSH host, and I'm going to give read permissions to that endpoint so that I can grab those credentials. So that's what I'm going to do by running the make vault init command. I'll copy that command and paste it. It's again going to ask me, do you want to log into these target instances? Or excuse me, that's the next command. What it's going to do now is we've already logged into Vault. That's what we entered in yes earlier when we copied the root token to our machine. And now that it's logged into Vault for us using that root token, it's now going to upload a couple policies, that boundary controller one that I mentioned before. It's going to upload the policy to read from that endpoint. It's going to then enable the KV2 secrets engine, and then it copies the SSH host secret to that path. At the very end of all this, the last thing that it does is it generates a token within Vault. So now that I've set up the SSH credentials, I've also uploaded the correct policies to Vault. What I also need to do now is set the ability for us to log into Vault from Boundary. And we do that using a token. That token is requested. You can see it inside of the setup.sh script. Just if you're curious how we grab that token from Vault, it's this client token section of the command that we just ran, where it executes Vault token create, and it also requests the correct policies associated that we just uploaded into Vault. So what you can see in the output here is that we have the Vault credential store token that was just generated. That is that token with those policies set on it. And later on, within Boundary, we're going to use this token to create what's called a credential store. So within Boundary, we can reference the credentials that are stored inside of Vault, and we call that a credential store. So all I'm doing at this point is I'm going to copy the token value that was just generated from Vault and export it as an environment variable. And that's it for Vault. We have now finished setting up Vault. We've initialized it and set the tokens that we need to access it. The very last thing here with kind of readying the lab environment is to create Boundary workers. Now, I mentioned earlier, a worker is the ability for us to reach into these private networks and allow Boundary to communicate with things like hosts. And essentially what we do is we place a worker in between the client and the host. What we're doing with our workers is that we are setting them on the same boxes that we want to access. So this worker, again, in a more realistic scenario, would be its own individual host that lives in the gap between the private hosts and the public internet. So it's going to forward connections from the clients to the hosts. Now, in this example, those are the same machines that we're logging into. We're running the Boundary worker service on those hosts, and it's forwarding the connections that we would expect. And again, we're just doing that to reduce the amount of cost for this lab environment. So if you're curious about that, we have, again, a bunch of tutorials you can step through to teach you about Boundary workers and how to deploy them. And if you want to see how any of that works, you can see these init scripts that are inside of the scripts folder that show you how we're setting up the Boundary workers and executing the Boundary service as well. So to set up our workers, we've created a couple of simple make functions here that will register the Vault worker and then also register the target workers. So to do that, I'll execute make register Vault worker. If you're curious about why we set all those environment variables earlier, it's so that we can run these make commands successfully. What's going to happen when I execute this make register Vault worker command is it's going to log into that Vault instance. It's going to generate a token for us, and that token we then need to use to tell Boundary to trust this worker. So this is what we call a worker-led authorization token inside of Boundary. And when we start up the Boundary service, we can request a token from Boundary. And then we can take that token to Boundary and say, you should trust this worker. This worker is OK for you to communicate with. This script went ahead and logged into Boundary for us using our administrator credentials and registered the worker within Boundary. I'm going to execute the next command, which is make register target workers, and also register the targets. Now, we've never logged into the targets before. We have logged into Vault previously. So it's going to ask me, do you want to log into this instance? And I'm going to type yes for both targets that are created. And it's going to step through the same exact process. It's going to stand up the worker service, and then it's going to register those workers to Boundary for us. To verify that this process ran successfully, I'm going to head back into my Boundary cluster UI. And off to the left-hand side, you should see a page or a tab called Workers. And clicking on it, these are all the workers that we now have access to within Boundary. The Boundary control plane, the HCP Boundary cluster, comes with a couple of workers preset for us. We call these HCP managed workers. And these are managed by the Boundary service itself. You don't get to spin up or control these. However, you'll notice 3 other workers here now. One of them is called Vault Worker. And this is one that we just registered with that command we ran to set up the worker. And so this is communicating successfully with our Boundary cluster. The command logged in, it registered this worker, and you can see this worker is tagged with a few different tags, including the Vault tag. This is how I can distinguish this worker from other workers, and what its function is by tagging these workers within Boundary. So I have a Vault tag associated with this worker, and we have 2 other workers that I've named AWS Worker 1 and AWS Worker 2. If I open them up and look at their tags, I have tagged one of them as the dev-worker, and my worker 2 I've tagged as prod-worker. That's just a quick way for us to distinguish which worker can access which targets that I've provisioned within AWS. You'll recall a moment ago when we executed the Terraform lab environment, if I check out the make Terraform output, scrolling through it, you can see the tags that are associated with these AWS instances that I just provisioned. One of them is tagged as the prod target, and the other one's tagged as dev. And so that's why I've tagged those workers associated like that. The prod worker is going to give us access to the prod target, and the dev one to the dev target. Excellent. So you're getting a quite real-world example of deploying all this content. So I hope this is okay. You're keeping up. Those are all the lab environment pieces that needed to be set up to go ahead and proceed with session recording. Now, to be clear, we're integrating Vault in this example, so there's a lot more complexity because we're using Vault to have it grab the credentials for these targets. But Boundary also has included in it native credential management. So you can have credentials within Boundary that are used to access these targets as well. You don't have to use Vault. We're simply showing off the integration with Vault today. So of course, there's another layer of complexity in setting up Vault and integrating it with Boundary. So to be clear, when you try this on your own for the first time later on, it'll be a little bit simpler if you don't want to integrate Vault. At this point, we're ready to continue setting up Boundary. Now, I've gone ahead in this tutorial and created 3 different ways for you to set up the Boundary resources that you might be interested in learning about. One, you can use the UI to manage all of the Boundary resources. So if you would prefer, we've written some great instructions here for you to set up all of the hosts and the credentials within Boundary themselves using the UI, which means you pop into this section of the UI that we've been demonstrating, and you would set up things like an organization, a project within it, and then a bunch of resources, including credential stores and also the targets that you would like to access. You can do all that within the UI, or you can also utilize the CLI if you would prefer to more programmatically create these resources. Including, again, the targets, the credential stores, the host catalogs, etc. Today, I'm going to utilize Terraform to set all this up for us so that we can skip to the part where we take a look at session recording, since that's what we're here to discuss. So feel free to utilize whatever workflow you think you would like to learn about as you go through this. And again, I'm going to use Terraform to skip a lot of that configuration. And to make it simple for you, if you choose to follow along with the Terraform workflow, in the lab environment, you'll notice these files in the root of the lab called boundary example. One of them is a terraform.tf file, and the other is a Terraform variable file, a tfvars. This boundary-example Terraform file creates all of the resources that we need within Boundary to enable session recording. There are quite a few prerequisites here in that within Boundary, we need to do things like set up what's called a organization, which is a way for us to scope all of our Boundary resources that we create. Within that, we can create what's called a project. And within our project, we can do things like set up a catalog of all of the hosts that Boundary should have access to. These are the hosts that we're going to import from AWS. Additionally, we want to do things like create a credential store within Vault. Within Boundary, we set up what's called a credential store, and this is a Vault credential store to tell Boundary the credentials for all of your hosts live in Vault. We then create what's called a credential library that tells Boundary what the Vault endpoint is, where it should search for our credentials. And then lastly, we have to set up the target and also the storage bucket. We mentioned here we're using Amazon S3 as our storage backend. And also, after setting up that bucket, we then need to create an SSH target type, which is what we're going to record the sessions for. Now, you can do all that within Terraform. I provided all these resources as examples for you. I'm going to set up the prerequisites for session recording with Terraform, and then I'm going to step through the UI with you real quick to show you what it looks like to create an SSH target and set up those resources that we're interested in for today. So you can do all this again using the UI or the CLI. I'm going to leave these last two resources for the storage bucket and the target commented out for now, so we can do that part in the UI to show off what that looks like. And the last thing that we need to do to utilize this Terraform configuration is set some environment variables that will be used by it. In order to deploy all this content, it needs access, again, to our AWS credentials in order to grab some of those hosts. We also need access to your Boundary username and password, an authentication method ID, etc., all of those values. And then we also need a credential store token that we exported on the command line a moment ago. To pass all these environment variables to Terraform super easily, we've created this tf-vars file. So inside of this is where I'm going to paste all of the content for communicating with Boundary. You'll notice I've pre-filled in a lot of this information, but I do need to update some of it because I just created a new Boundary cluster. So I have a different cluster address. I might have a different cluster password. And then I also need a new authentication method ID, cluster ID, and Vault address and Vault token, and also the IAM credentials for accessing the hosts in AWS. So there's quite a few environment variables to fill in here. And to get most of these, firstly, I can go ahead and echo the ones that exist that I've already defined. So within the tutorial here, I have a quick command for you to locate some of these environment variables within your shell session so that you can copy them into the tf-vars file if you choose to follow along with this workflow. So I've exported or echoed a lot of those environment variables we used earlier. I'm going to grab the Vault address first, or excuse me, the Boundary address. I'm also going to grab the cluster ID, which is that prefix to the .boundary.hashicorp.cloud, and paste that in for my cluster ID. I'm then going to also copy the auth method ID and paste that into the appropriate variable. And then I also need the Vault address and the Vault token. Excellent. The last piece that I need is a host catalog access key ID and a secret access key. Now, this is not the content that I've used to log into AWS. Those are separate credentials. When we executed the Terraform run earlier, it created an IAM user for us to be able to log into AWS from Boundary and list the hosts that exist within AWS. This is important because I don't want to use the admin level credentials to do everything, right? I created a separate IAM user that Boundary should be using to access these hosts. And what happens with this is it just has access to the EC2 describe instances call. So we're able to list these hosts and then utilize them within Boundary. To grab those values, I have a handy little command for us here. Which will allow us to select these sensitive values from our Terraform output. So you'll recall earlier when I ran make Terraform output, what we need access to here is the host catalog access key ID and secret access key. These are sensitive Terraform outputs, so it doesn't display them in the output of the Terraform, the built-in Terraform output command. To grab them, I need to locate my Terraform TF state file and grab the values directly from them. And it looks like I have a command we need to update here. Yeah, so apologies for this. You can grab this value manually from the TF state file if you would prefer, but it looks like I just misnamed the environment variable here. So my apologies. You'll have to either rename the environment variable to be capitalized. There we go. Or you can grab these values directly from the TF state file, which is all this command is doing, is opening the TF state file inside of the infra directory. And copying the values directly from it. Right. So I'll make sure that command is fixed for anyone that wants to try this at home. The purpose here is that I'm going to copy this value, open up my TF-vars file, and place that in there for the ID and the secret access key. OK. And at this point, we have all the variables defined that we need to provision these resources within Boundary very quickly. All right, so now that I've gone ahead and done that, I'm going to execute Terraform init, and then Terraform apply. And I'm going to pass in the variables file to the Terraform run that I just created. I will confirm that I want to create these resources within Boundary. And I was hoping to beat it here. Something always has to go wrong. What essentially has happened here is our Vault token has expired. Gotta love that. Happens so fast. So I do believe I have a troubleshooting section inside of here if this does occur for you. Of course, it needs to be. Is that what's going on? Yeah, and I think I was just mentioning here that Inside the tutorial, if you do run this in the future, I did set up some simple ways for you to troubleshoot this. But Yoko, maybe those changes didn't get merged. You don't see them? Gotcha. Great, so I apologize. I did have an accordion where I put these troubleshooting steps. They should be there. But yeah, absolutely. So the fix to this is just a Vault login with the Vault token here. I've now got that token, and then I'm going to create a new Vault token for me. And as you mentioned here, inside of the make file or inside of that setup.sh script, we have the command to create that token for us. And you can even copy this nice part to run the export bit if you would like. And now I have my new token. I'm going to copy that into my TFRs file. Save that. And rerun Terraform. All right, there we go. So the token worked as expected. They expire so fast. All right, so now we have all the prerequisites set up for session recording. The last thing to do is create a target within Boundary and set that up. So to do this, I'm going to utilize the UI to make it pretty simple to show you how this works within our nice, beautiful new UI. I guess I just want to show it off. So I'm going to utilize the UI here. And inside of the steps as you follow along, we have the ability to set up first what we need to do is the storage bucket within Boundary. So under the create a storage bucket section for the UI, I've set up a bunch of simple kind of names and other values you can use. Heading back into the UI for Boundary, I want to click on the storage buckets section and add a new storage bucket. So it's pretty nice. The UI allows you to go ahead and just name your bucket. You then need to choose a scope. And this is what I did with Terraform, is I created a couple of preset resources for us within Terraform. A session recording organization. And now I need to grab the name of my bucket from AWS. This is part of the Terraform output that was generated earlier. But I do have a command here for it to copy that bucket and just print its value directly, so we don't have to fiddle with locating that. So here's the name of my bucket within AWS, the demo bucket. The region is going to be US-East-1. It's a static credential. And then for the access key ID and secret access key from the Terraform output, these are the IAM users that are used to access S3. So you'll find those in the Terraform output as well. But I went ahead and echoed them in this nice handy command I put in the tutorial for you so that I can copy that access key ID and the secret access key. Lastly, I need to specify what worker should be allowed to use for contacting this storage bucket. I'm going to let any of my workers contact the storage bucket. It's a simple way for us to say, for whatever target I'm accessing, it's allowed to speak to the S3 bucket. And so that way I don't need to proxy through multiple workers to reach S3. And in order to do that, I'm just going to grab the filter that's associated with my buckets. Now, I've tagged all of the workers with this, so it'll make it fine. But the point of this is you typically route through a worker that has access to S3 if you wanted to use a private bucket. That's the point of that. Lastly, I'll disable credential rotation. We're not using credential rotation in this example, and I'll click Save. It successfully was able to contact my bucket, and under the storage buckets, I now see my new SSH test bucket that's contacting S3. And now I'm ready to set up a target within Boundary. Clicking on orgs, I'll notice this session recording org that I set up using Terraform. Clicking on it, I'll see a project that I've named SSH Recording Project, also set up with Terraform. And within it, I also have a host catalog that was set up that contains all of my AWS hosts. This is the point of that automation, is that I was able to import these targets from AWS directly into Boundary. And so this host exists inside of here. You'll notice I have a filter set on it for an environment of dev. And I also have a host set called prod. Additionally, I have a credential store that's keeping my Vault host credentials inside of it. So this credential store is a type Vault. It has the address of my Vault cluster. It has the token for my Vault cluster. And it also has a credential library that contains the endpoint where I should contact Vault for credentials. So I did all that using Terraform in order to set up this integration to grab those credentials from Vault. And with this, I can set up a new target. I have some suggestions for the names inside of here. Dev recording target is what I want to call the first target. It needs to be an SSH target type. So making sure you select the target type of SSH. I'm not going to set a target address. Instead, I'm going to use what's called a dynamic host catalog, which imported the hosts from AWS for me. I'm going to state that it should contact this target on port 22, and that I'm going to use a -1 here under connections to specify that I can allow an unlimited number of connections to this target. Not going to limit how many SSH connections can come in this example. Lastly, I'm going to specify that I am going to use what's called an egress worker filter. You'll recall from this setup here, we have a worker that provides access to our hosts, and that is called an egress worker. However, I could also have what's called a multi-hop worker, where I have multiple workers proxying the connection to my targets, and that's what's called an ingress worker. We don't have multiple workers in this example, so I'm just going to enable the egress worker. And our workers, as I mentioned, are tagged as well. For the dev worker, I have a target tag called dev-worker. So this tells Boundary, in order to contact the target called dev, use the worker tagged as dev worker. Placing this in for my filter, I'll click Save. We've successfully created that target, and I'm going to tell it, in order to access this target, I want you to look at the hosts that you've imported from AWS, that dev host set. The host set contains the target address. So the host set is dynamically managing which hosts I'm allowed to use from AWS, and I'll click Add Host Sources. And then I want to add injected application credentials. You'll recall from the beginning of this talk that injected application credentials are the ability for us to immediately have Boundary inject credentials into a session so that the client never receives any credentials. I'll add those credentials that will be accessed from Vault, and now this target is fully set up. Under the Details section, there's a section called Enable Recording, and clicking on it, I have to toggle the switch for record sessions for this target, and I'll click the storage bucket called SSH Test Bucket I set up just a moment ago. Clicking Save, I have successfully saved my configuration for session recording, and now all that's left to do is to log into that target and record a session. This is where the Boundary desktop app comes in handy. I want to have my cluster address available for that. So I will echo that Boundary adder from before and make sure that I have it copied. And now I'm going to open the Boundary desktop app. In the Boundary desktop app, I place in my cluster address. I'm going to use the admin credentials to log in here, but as an end user, right, everything that we just did is the administrator workflow to set this up for the end user. Now I'm putting on my end user hat. I want to log into that box and I want to do some work. Maybe I want to manually check some logs. Maybe I want to update a networking configuration. Maybe I want to update the content for a web server. In this case, I want to log into that box. So I log into Boundary using my credentials, which would not be admin credentials in the real world. And then notice I have my target that I just set up. That's available to me as an end user. I've specified that this user is allowed to see this target, and you'll notice a connect button for that target. Clicking connect, I have requested a connection to that target, and Boundary has verified that yes, this user is allowed to talk to this target. With all the users that log in via OIDC, LDAP, any method that you can use to log into Boundary, I can specify what they're allowed to do. I, as the admin user, am allowed to talk to these clients. And you could take these credentials, this local proxy that has been created by Boundary, and you could log in on the command line. Today, or this conference, we released a new feature for our desktop client called the shell session here. And directly within the Boundary desktop app, I can click on shell. Now, did you see what just happened? I didn't enter in any credentials. I didn't do anything to talk to this box. Boundary instead injected the credentials directly from Vault into my session for me. As the end user, I never saw those credentials. I don't know what they are. Boundary can also rotate them or use certificates instead. So as the end user, all I have to do is say what box I want to connect to, and Boundary securely proxies my session from my local machine to the end target. Now I'm on this machine. I can run some commands. I'm not much of someone who's going to grab passwords from this machine, but maybe I'm going to run something slightly nefarious like netstat. After I've done some things that I might want to review later during an audit, I can then close my connection or end the session within the Boundary desktop app. And now that that session has ended, we want to go check and see if it was recorded by Boundary as expected. That's the whole point of this, is that not only can I establish sessions to my targets, but the goal of today's session was to enable recordings for those targets. Back in the Boundary desktop app, or the admin UI, at the top level, you'll see something called session recordings, and you'll notice a new recording was just completed from the dev recording target. Clicking on View, I'll have the ability to do things like play back that recording. You can see the amount of data that was transferred during that session, the length of the session. You can see the target and who accessed it, and the session recording itself has an ID. Clicking on Play, it will then load up a video of the session, and I can click on the playback to play back the session as it just occurred from that user. If I skip ahead a little bit from when I was talking, you should then be able to see me running commands, such as netstat. And you also have the ability to download these recordings from the storage bucket and view their contents locally. So I'm over time by a few minutes, but I want to thank you for coming to check out this demo. I know there were a lot of pieces that we worked with today, and it sounds like a lot of you haven't worked with Boundary yet, so I hope this doesn't feel too intimidating, because this is an advanced workflow that we set up today, integrating Vault, deploying all these components with Terraform, right? And so I encourage you to check out developer.hashicorp.com and look at some of our quick start tutorials to help you dig into these in a little bit more appropriate of a pace. Thanks so much for your time, and thanks for joining us at HashiConf.